Good morning, geometry. Well, we got another class time together, and today we're going to look at section 18-3, where we're going to find the volume of cones. And big question we're going to ask is, how do you calculate the volumes of composite figures that include cones? So again, composite figures are geometric shapes that have more than one type of figure. So again, we may be, within this section, tying in stuff from 18.1 and 18.2, but now we're also going to include cones. Again, just like an ice cream cone. So the one thing we're going to look at here is in this section, they show us in the Explorer part how to develop the volume formula. Again, I'm not really interested in doing that. Again, it's not really relevant, so we'll just go right to the meat of the matter, okay? So if you go to your page 951, again, if you look at the definition right here, this is the definition how to find a volume of a cone. And it's nothing more, again, we could do it one of two ways. Volume is 1/3 times the area of the base of the cone times its height, or we can use the other formula of the volume equals 1/3 pi, which we are going to use the pi on the calculator. We're not going to go and do 3.14. So 1/3 times pi times the square of its radius times the height. So that is what we're going to use. It's also, again, it's shown on your HT&Cs. Again, that is one of those formulas that you can memorize. So what I want to do is, just by way of example, is just do some different examples. So on page 952, what I like you to do is, let's just go over example 1, and then take a moment, and I want you to pause the video and try the year turns number 2, 3, and 4 on your own. So here's our problem. We have a figure on the right that represents a conical paper cup. And the question we're asking here is, how many fluid ounces of liquid can this conical paper cup hold? And they want us to round the answer to the nearest tenth. Now, they gave us one hint in here. They're telling us that 1 cubic inch, that means if we have a cube that's 1 inch by 1 inch by 1 inch and it holds a liquid, it is roughly equivalent to 0.554 fluid ounces. All right? Now, that is something that you probably talked about or talked about when you had physical science. So I'm really not going to go into details on that. So there won't be too, again, this is just a conversion factor. I mean, I'm not going to go over that too much in this section. So letter A, find the radius and the height of the cone to the nearest hundredth. So if you look at your diagram, all they're giving us is the diameter of our cone, and they're giving us this side, which we call the slant side of this cone. And if you look at it very closely, they have a right angle right here. So that tells us from the radius here and this height, we're going to make, this can be treated like a right triangle. And they're telling us right here that the hypotenuse of that right triangle is 1.8 inches. So the directions are finding the radius and the height. Well, the radius is going to be very difficult. We already know that the radius is going to be 1/2 of the diameter. That's obvious. But now, to find the height, we're going to have to use the Pythagorean theorem. All right? So the Pythagorean theorem, once again, is the length of one side squared plus the length of a second side squared must equal the length of the hypotenuse squared. And that's what they have set up here. And all we had to do now here is to find the height is just algebra, find h. So again, they did all the work for us, and they found out that the height is roughly 1.42. Now again, they got that by taking, to get this h by itself, we have to do the square root. Okay, so the square root, so second x squared of 2.03 is 1.42. Now they went and rounded it to the nearest hundredth, I think they said here, but our final answer is going to be to the nearest tenth. All right, so now the reason we need all this information is if we want to find the number of fluid ounces, we've got to be able to find the volume. So that's why I have the formula set up here. We have all our information. So now we get to find the volume of that. So the volume of that, once again, is nothing more than 1/3 times pi times our radius squared times our height. Now again, they have 1.8, so what I'm going to do is just show you on your calculator. This is how I would do it. Okay, you don't have to do it this way. I'm just doing it because it may help alleviate some problems of that you didn't get the right answer. So the first thing I would do is, first and foremost, think of this as the order of operations. So I'm going to take care of that product right there. So parentheses, second shift button, that gives us pi times 1.1 squared times 1.42. Close that up with parentheses, that takes care of this part. Then I'm going to divide it by 3. And I got 1.79, so we round that to the nearest tenth. So the volume of this cone, okay, holds 1.8 cubic inches. Now the next part is finding the capacity of the cone. In other words, how many fluid ounces are held in here. And we already know that 1 cubic inch is equivalent to 0.554 fluid ounces. So we already found that this is 1.8 cubic inches. So it's very simple. If you take 1.8, in this case, 1.8, and if you multiply it times the conversion factor of 0.554, you'll get 0.9972, which roughly gives you 1 fluid ounce. All right? So, nice problem, multiple parts. Just got to take your time. You guys can do this. Got to take your time. We're dealing with volume, so there's a couple things we need to know. We need to know what the radius is, and we have to know what the height is in order to find the volume. But now this problem was asking you to find out how many fluid ounces can fit into that conical cup. All right, now stop the video and try your hand at the your turn. All right. So do it, stop your video, take your time, work it out. All right. All right, you're back. Here is our second problem, your turn. Right after Cindy buys a frozen yogurt cone, her friend Maria calls her and they talk for so long that the frozen yogurt melts before Cindy can eat it. The cone has a slant height of 3.9 inches and a diameter of 2.4 inches. If the frozen yogurt has the same volume before and after melting, and when melted just fills the cone, how much frozen yogurt did Cindy have before she talked to Maria? And they wanted you to do the nearest fluid ounce. And then here's all the setup. Very similar to what we did up here. Okay. Again, I'm not going to go over that. You guys can figure that out. All right, the next thing we want to do is how to find the volume of a composite figure. It seems like every time I get on a video, I get a little tickle in my throat. Find the volume of a composite figure. Now, once again, a composite figure is a figure that has more than one geometric shape. So when you look at your problems, you got to ask yourself, you got to be able to know your differences of all your volume formulas. All right. So again, they gave us example 2, and they did it in 2 parts. Part A is they found the volume of the cylinder, which is pi r squared h, which is in the last section. Then they found the volume of the cone, which is 1/3 pi r squared h. Now again, you got to do a little bit of thinking here, okay? You guys can handle it. And they wanted you to find the total volume. So that's example 2. All right, let me see what's next. Okay, the year turn. I think that's the last one I want to do on this video. I do believe so. Maybe or maybe not. I don't know. Nope. I think it is. All right, year turn. Making a cone-shaped hole in the top of a cylinder forms a composite figure. So again, trying not to show everything here. We have a cylinder here, and dug out of the cylinder is a pyramid. So making a cone-shaped hole in the top of a cylinder forms a composite figure. It's composed of the cylinder and the rectangular, not the rectangular, but the pyramid. Find the volume of the figure to the nearest tenth. So again, now this one is set up so that we have to find the volume of this whole figure after we have taken the cylindrical cone out of it. Now up here in my right hand corner, just for my purposes, I've been doing this since my college days, is we know that the volume of a cylinder, I made a picture of a cylinder here, we know it's pi r squared h. A volume of a pyramid or a cone is, I made it look like a cone, is 1/3 pi r squared h. And in order for us to do the composite of this, just to let you guys know, I didn't do all my work here, is to find the volume of this figure, we need to take the volume of the cylinder and subtract from that the volume of that cone. That's that cone we're cutting out. So the first part here is, in the number 6, is find the volume of the cylinder. Again, we have to figure out what our radius is, which again, they just show the diameter. So the half of the diameter is your radius. And here, once again, using our calculator, we go second shift, times 1.8 squared times 4.3, and rounding it to the nearest tenth, we're going to get 43.8 cubic centimeters. Please don't forget your units. All right, to find the volume of this whole figure, this composite figure, you take the volume of the cylinder, which we found, and the volume of the cone. Now I wanted to show something here, okay? If you look at the volume of the cone, you're going to notice that the volume of the cone has this part as the part of the volume of the cylinder. So if you look at it, we know the volume of the cylinder we found already in part 6. The volume of the cone is 1/3 the volume of the cylinder. See how this is pi r squared h, the volume of the pyramid, or the pyramid, and the cone, and this is the volume of a cylinder. They are the same values, so I can take 1/3 of that. So again, do your math, which you can use your calculator, and if you work this one out, you get 29.2 cubic centimeters. Now, ladies and gentlemen, that is section 18-3, finding the volume of cones, whether you're finding a volume of a cone or you're doing a composite of a volume of a figure. I think you guys will have no problem with this. All right, if you need to watch the video again, please do it. But that's it. Again, chapter 18 is relatively easy. I like that in geometry. Towards the end of the school year, some of the sections are just so much easier compared to what we've been doing at the beginning of the school year. All right. Thank you, guys. Catch you later.